Okay. Okay, Ji, recording is being started. So, okay, Ji, is it okay? Now,
जी सर.
let's start with this. I hope everyone is viewing this slide, and this is a just a book snapshot on the right side, and copyright is to authors. So because they have allowed it for use in the classroom, and I have made little bit of changes in it, adapted it accordingly. So okay, so let's start with chapter 1. This is the chapter 1 introduction, and basically, if you recall, this is the title of the book is top down approach. So this first chapter will give you a overview or big picture of networking. So this is very important in this context, that if you miss this, so you will not have a overall feeling of networks. So this is something in this context you have to uh, get a complete concept of it. So what we are going to study in it, basically we will be starting with what is internet, and then we'll be talking about what is protocol, and then we'll be talking about network edge, the devices which are at the edge of the network, and then there is a core of network, and we will talking about the methodology of a core of network, and then performance related issues. We'll do a brief discussion on security, and at the end of this chapter we'll be talking about protocol layers and their service models. Okay, ji. So let's start with the nuts and bolts view. Again, the basic view, the big picture of internet. So this is what we have, that you know we have billions of connected devices. You know, for instance, smartphones, wireless laptops, desktops, and many other devices which are basically connected with each other, right? So these devices, we for our understanding, we will be calling these devices as hosts or end systems. That these are hosts, and for this understanding terminology, we will calling it end systems because they are connected at the end of the network. If you look at the right side of this slide, you will see one internet. What is inside it? This is something, a topic of this course. We'll be going to study it, but just a big view, that there is a internet. What is internet doing? I will talk about it, but these are the end systems. These laptops, the smartphones, maybe a system, computer system in an automobile. These are the servers. So all these are located at the end of the network, and they are connected devices. They are connected to each other with the help of through the internet, right? And these end systems, they are running various apps, network apps, and they are located at the edge of the internet. So that's why they are known as end systems or something like that. This is not a universal definition, but just for understanding purpose, author has used this terminology, that end systems, that they are located at the end of the system. So any device which is located at the end of the systems, like I have given you various examples of it: phone, automobile, computer system and automobile, laptop, servers, desktops, sector, all they constitutes host or end systems. Then basically, as I told you earlier, that these end systems are connected to each other through internet. Now, what is inside internet? So look at this. So we call them as routers, and these, the X sign which you are seeing, these are basically routers. Again, pronunciation is routers, not routers. So please be careful in pronouncing it. It is pronounced as routers. Okay. Then we have this, rectangular shape X sign. These are known as switches. We'll talk about them later on, that the details of it, the working inside, how it works. But again, these are the two main devices, core devices in the internet, routers and switches. What they do, basically, end systems which are connected to each other through this internet, basically they generate data. They generate data, right? And data we call them as packets. So there is a standard term which is known as packet. What is packet? Packet is a chunk of data. Means that your system and systems, they generate digital data in terms of bits. So we group the bits, group of bits, you can call it as packets are to that.
एक्सक्यूज मी सर, आपकी वॉइस डिस्टॉर्ट हो रही है।
And switches do well, we call them packet switches. General term is packet switches. So they forward packets. The other, you may be wondering that they are standalone devices. KG, these routers are, are the not only the part of internet. There must be something else which is connecting these routers together. So what are these? The third component is communication links. So these communication links are basically connecting these routers to the various end systems. So communication link can be of various types. It can be a fiber, optical fiber, it can be a copper, it can be a radio link, it can be a satellite link. So there can be variety of communication links. And the transmission rate which we use is known as bandwidth. We call it as bandwidth. We measure the transmission rate in terms of bandwidth. Bandwidth means generally bits per second, and the you can have a kilobits per second, megabits per second, or even gigabits per second. So bandwidth is measured in terms of bps, and overall we say that higher the transmission rate is, the more fast you can get the data. Okay, so this is what we have, three basic components in internet. Have a look on it. Normally I give you some time for thinking before switching to next slide. So have a look on it. If you have any question, you can ask, but at the end you will have networks. Now what is networks? The fourth part is known as networks. So these networks are basically collection of devices. So look at this. So before that, if you look at this, let me go back a little while. So look at this internet. Now this internet you are seeing here basically as a single network, but practically it is not a single network. It is a collection of networks. Collection of networks. Look at these blue islands, blue color islands. So these are collection of networks, and basically these networks have the same devices which I have told you earlier, that they have devices and systems, routers, links, and they are managed by different organizations. So let me tell you that internet is not owned by a single organization in the world. These various networks are owned by, managed by different organizations, and they have different kind of networks, right? So these are the four major components of today's internet. Have a look on it. I'll give you 1 minute to recap the things, and then if you have any question, you can ask. Okay, ji. Okay, any question, ji, please? Can you hear me, ji?
जी सर.
Okay, okay, I assume. So you don't have any question. So again, highly encourage ask questions, right? So otherwise, okay, I'll move to next slide. Let's go to next slide. So these are some devices, interconnected devices, various devices you see here. Normally, our minds do not go to these devices that they can also be connected to internet. But these are the devices. You can have a, for instance, IP picture frame, which can change picture. You can have a slideshow, and you can see the pictures, different pictures at different times. So refrigerators, cameras, and various devices which you are seeing here, they all can be connected to internet. They are connected, in fact, not can be. They are connected to this. Okay, ji. Now let's move to again uh, the internet. We have in a slide before last slide, we have said that we have end systems, we have routers, switches, communication links, and connected networks. Now we go into further detail. Recall that I said, look at the right side diagram. This is the same diagram which was shown to you a little while ago. So this is something, again, connected networks and end systems and router switches, packet switches, and various communication links. So look at this. These are the connected networks. These are different blue color, islands. They are networks. Now the question is this: that little while ago I told you that basically internet is not owned by a single person, single company, single organization. In fact, there are set of companies, organizations which basically own the internet, and different networks which you are seeing here, they are owned by different organizations. So who basically connects these networks of networks? So the answer to it is ISPs. ISPs stand for Internet Service Provider, and they basically provide this connectivity to overall internet, right? Then comes protocols. Now protocol is a standard terminology, and it is being used in internet. It's a common term, universal term, so it's very important that you should understand this term, that what is protocol. So you know I'll give you a example to have a better understanding of protocol. For instance, in a classroom environment, you know when instructor is delivering a lecture, so naturally students may ask questions, right? Now, what can be a scenario that suppose that 4 or 5 students want to ask a question from an instructor, and instructor is delivering a lecture. Now, if those 4 or 5 students, they start asking question at the same time, then what will happen? Your instructor will not be able to listen to the questions of those students because they are speaking at the same time, and the instructor would not be able to understand what each student is asking. So therefore instructor says that let's devise a protocol for asking questions. A protocol is a set of rules in this context, and instructor says that if you want to ask a question, raise your hand. this would be a rule for asking a question, that if anyone from the class want to ask a question, raise your hand, and then instructor will ask a certain student. Naturally 4 or 5 students will raise hands because they all want to ask a question. Then your instructor will point out to the certain student one by one, that okay, you ask question, then next ask question, then next. In this way, what will happen, that instructor has devised a rule for asking a question. So this we can call it as a protocol, that we have devised a protocol for asking a question, answers. So this is something, example of a protocol. So in network terminology, there are various types of messages are exchanged between end systems. So therefore, protocols are needed to exchange those messages. There is some messages which are known as controlling sending and receiving of messages. For instance, multiple devices, they communicate with each other, and therefore you need a protocols. Example of protocols are HTTP. I assume that you are very familiar about it. Hypertext Transfer Protocol. Then we have streaming video, Skype, TCP, IP, Wi-Fi, 4G, Ethernet. So these terms are maybe new to you, some of the terms, but again, as this course will proceed, you will have a better understanding of these protocols. But meanwhile, you should understand what is protocol, what is something which is protocol. So as I told you earlier, basically these are rules, regulations by virtue of which communication is done between different end systems. So then we have standards. So we need standards. Why we need standards? Can anyone tell why we need standards?
सर इंटरनेशनली इम्प्लीमेंट करने के लिए.
Okay. Anyone else? So online classes as a unique characteristics, that your instructor is not able to see you, that you know therefore please participate actively in the class and listen to lecture with full concentration. So this is a kind of advice. So inshallah, assuming that we will have only 2 online classes, so face to face classes will have better you know interaction between instructor and students. Okay, G, anyone else would like to explain or share what is a standard? Again, okay, G, anyone else? I would like to hear voice of any other student except your Sia. G, 04 is here.
Yes, sir.
So can you share your thoughts? Standards क्या समझते हैं आप?
सर नहीं मुझे आइडिया इंटरनेट स्टैंडर्ड के बारे में.
नहीं, मैं जनरल स्टैंडर्ड की बात कर रहा हूँ बेटा. इंटरनेट स्टैंडर्ड तो मैं आपको बताऊंगा ना.
जी सर.
मैं तो
सर
स्टैंडर्ड की बात कर रहा हूँ.
जनरली स्टैंडर्ड देखा जाए तो मतलब होता है ना कोई स्पेसिफिकेशंस जो सेट कर दी जाती हैं. फिर
Okay. Okay, that's fine. So anyways, basically standards are required for interoperability. The main you can say the reason for standards is interoperability. For example, so naturally specifications are set, common specifications, common you know way of doing things are set by some organization. So who creates standards? Basically, standards are created by some organizations, national level or international organizations. Uh, why? Because suppose that you are having a. I hope everyone is having a uh, LCD or television in their homes. Now, televisions are manufactured. Suppose that there are no standards. Suppose that there are no standards. So what will happen? The, let's say that you have gone abroad and you have purchased a television. So that company which has manufactured the television may be manufacturing it with their own country methods, and that may not work in your own country. So it is quite possible. So therefore, for interoperability throughout the world, throughout a certain region, we need standards so that it basically is operatable in every part of the world using a certain methodology, common specifications. So now these standards are basically required, and internet is also having standards. Now internet standards are basically having a little bit different name. We call them as RFCs. Internet standard is known as RFCs. We don't call them as standards. In fact, the typical name which is given to internet standards is known as RFC. RFC stand for request for comments. So as I told you earlier, there are various protocols, and each protocol is having a RFC and some number. So for if you are interested, you can go to rfc.org. So there are some public standards which are freely available. For example, HTTP is a public standard, open standard. So you can download the standard from there. So HTTP has a certain RFC with its certain number. So in internet terminology, standards are known as RFCs. So you have to keep this term in your minds, that internet standards are known as RFCs. So there are various internet standard organizations. The one of the, for instance, one of the internet standard organization is known as IETF, Internet Engineering Task Force. This basically, the job of this IETF is, this is a standard body, internet standard body. Basically, it looks at operational issues of internet. It looks at operational issues of internet, and it devises methods for operational issues. Then there is a Internet Research Task Force, IRTF, that basically works for devising standards for future of internet. So this is something, these are standard organizations. IAB, there are different standard organizations for internet. Internet Architecture Board, IAB stands for Internet Architecture Board. IETF stands for Internet Engineering Task Force. IRTF stands for Internet Research Task Force. So this is what we have about internet standards. So again, as the summary of this slide is this, that internet is a network of networks, and we have protocols. Protocols are used for communication between different end systems, and then we have internet standards, right? So I've given you a classroom example. Protocol, understanding of protocol is especially very important, that you should have a thorough understanding, clear understanding of protocol. Let me give you another example. Suppose analogy from real life. Suppose that there are two persons, and they basically can speak only one language. For instance, one can speak only Urdu, and the other one can speak only Japanese. So now they want to communicate with each other. They want to communicate with each other. So how they can communicate? So naturally, they need to devise a certain protocol for communication. Obviously, they cannot understand each other languages, so they cannot communicate with each other directly. Let's say that they devise a protocol. They say that we will hire a secretary who can speak two languages. Each one of the person, which I have told you, they hire a secretary which can speak two languages. For instance, the person who speaks Urdu, he hires he or she hires a secretary, basically, which can speak only, which can, let's say, speak two languages like Urdu and English. And the person who can speak only Japanese, he or she hires a secretary which can speak Japanese and English. So what will happen? So you can understand the scenario, that Urdu is converted to English, and then that is transmitted to the other secretary, and that understand English also, common language English, and then he or she interprets, translates it back to Japanese, and in this way, communication can occur. So this is how basically a protocol can be devised. Okay. So have a look on it. If you have any question, I'll give you 30 seconds almost, so that you can have a review what we have discussed. Initially, I would be slow because we are developing concepts. So naturally, as the course will proceed, things become fast. Okay. Okay, ji, is it okay to everyone? किसी को कोई question है तो you are welcome.
सर ये जो आपने एग्जांपल दिए प्रोटोकॉल की, इसमें एनोलॉजी क्या है प्रोटोकॉल के अंदर? मतलब कि जो आपने जापानीज और एक पर्सन है जो जापानीज और इंग्लिश पढ़ रहा है, तो उसकी एनोलॉजी प्रोटोकॉल में क्या है इसमें जो हम पढ़ रहे हैं कंप्यूटर में?
इसमें तो एनालॉजी नहीं होगी बेटा, इसमें तो एक्चुअली होगी कि आपके लेखें एक कंप्यूटर है, उसके अंदर विंडोज का ऑपरेटिंग सिस्टम है, राइट?
यस सर।
और दूसरा कंप्यूटर है, उसके अंदर लेट्स से एप्पल का मैकिंटॉश का ऑपरेटिंग सिस्टम है। तो आप दोनों के ऑपरेटिंग सिस्टम्स के जो है ना, जो फॉर्मेट्स हैं वो डिफरेंट हैं। तो अगर डाटा जो जनरेट होता है उनके, अगर आप डायरेक्टली कम्युनिकेशन करेंगे तो विंडोज की जो फॉर्मेट है वो मैकिंटॉश नहीं समझ सकेगा, ठीक है? जो एप्पल का सॉफ्टवेयर है कोई, तो यू नीड अ कॉमन लैंग्वेज. So common language to communicate these different operating system is basically protocol.
ओके
Okay, Ji, is it okay to everyone? Okay, let's move to next slide then. Now let's have a look on internet service view. If you look at here, again same diagram which we are using. So infrastructure is required. What is infrastructure? Infrastructure, basically there are various applications which are running in internet, and for instance Skype is running, or email or video, web streaming, multimedia, tele. Basically that provides the service.
Sir, your voice is not clear.
Then it can provide a
Sir, you are not
programming
audible.
interface. Gee, is it okay to everyone?
सर आपकी आवाज़ लैग कर गई थी, तो कुछ भी स्लाइड का कुछ समझ नहीं आया।
नहीं, वो थोड़ा सा इंटरनेट के अंदर प्रॉब्लम आ जाती है। अब आ रही है ना आवाज आप लोगों को?
जी सर, अब आ रही है।
Okay. So infrastructure is there. So look at this slide. So basically infrastructure, internet basically provides you infrastructure. Infrastructure means that this, these routers, these communication links, they all comes into infrastructure. And this infrastructure is providing various services to applications which are running at different end systems. What are those applications? For instance, streaming video, multimedia, teleconferencing, email, games, and there are various applications which are running in different end systems, and internet is providing infrastructure to those devices, to those services. So this is a one view of internet. Another view is that it is providing a programming interface to distributed applications. So distributed applications means that applications are not placed in one end system, one or two end systems. There are billions of devices, connected devices, and those applications are distributed in each devices. So internet is allowing you, hooking you, connecting you, sending, receiving apps to use internet transport service, and it provides you various options, service options. For instance, in a normal postal service, you can have a normal letter send. You can send a letter. You can also send it through UMS. You can also send a registered email, letter. So there are various services available. So same thing is internet, and internet is also providing various service options, right? This is something. So infrastructure and programming interface. Have a look on it, and if you have any question, welcome. Okay, Ji. If no, then let's move to this. So again, protocol, I have given you example, lot of analogies and examples. So, another slide for explanation of protocols. That human protocol means that there is another example given by author, that suppose you want to ask a time. So naturally you will, you know, maybe exchange greetings with each other, and then you will ask a time. And again, I have a question. I have already given you introduction, and then in a little while ago, that if you want to ask a question from instructor, these are human protocols. Suppose you want to introduce each other, so naturally, one by one, you will be devising certain methods for giving introductions. So this is something which is basically human protocols. So what will happen in human protocols? Specific messages are sent, and then actions are taken. For example, in a classroom environment, when you ask a question, specific message is sent. In this context, the question is being asked. Then action is reply to that question, right? So specific action taken when message received or other events. There may be other events are triggered. So in case of network protocols, you can think like this: instead of humans, we have computers, devices rather than humans. And all communication activity in the internet is governed by protocols. So this is protocol is everywhere in internet. So all communication activity is governed by protocols, because two devices, they cannot understand each other without having a common protocol. So what, technically or by definition, what protocol defines? Protocol defines the format, order of the message sent and received among different network entities, and then actions taken on message transmission or receipt. So this is a standard definition of a protocol. Have a look on it. Okay, Ji, is it okay to everyone?
Yes, sir.
Okay, let's move to the next slide. So just again another example, because protocol is so important that we are spending enough time on it, so that you can have a better understanding. So I'll give you, show you little animation for a human protocol and computer protocol. Have a look on it. I'll not give lot of explanation on it, because we have already discussed this, just to strengthen the concept let's have a look at this animation. Let's talk about first human protocol. So in this is a human protocol. So you know, if you look at your left side, these are two figures and persons. One is the in. Let me tell you that in internet terminologies, in computer networking, we use, in normal engineering we use X and Y or Z, but in case of computer networking we use names, and the standard names are used. For example, this girl is Alice, and this boy is Bob. So these are the two standard names which are used to give examples. So suppose that Alice wants to communicate, wants to ask a time from Bob. So she says hi, and then Bob replies to that greeting, and then got the time, and then time is given. So this is a human protocol, right? So we have already discussed other human protocols. I'll not ask you about. There are many examples can be given for human protocols, but I'll not ask from you. Think about them, by the way. Now look at the computer protocols. So this is something a human computer protocol in right side, that there is a end system computer and there is a server. So TCP is a example protocol, transmission control protocol. So connection request using TCP protocol, and suppose server replies to that connection request, and he allows the connection, that server allows the connection, and then what happens that then client, the computer, basically requests a page from server. For example, this is a page of a book, this book, you can have a look on it, and then the file is given from the server to the computer. This is an example of computer network protocol. Okay, Ji. Any questions? If you have any questions, welcome. Okay, let's move to the next slide.
एक्सक्यूज मी सर
Ji, please.
सर अगर मैं कहती हूँ आपसे एक्सक्यूज मी सर, फिर आप रिप्लाई करते हैं यस, तो फिर और मैं फिर आगे से अपना क्वेश्चन करती हूँ, तो ये भी एक प्रोटोकॉल की एग्जांपल है.
Bilkul, but you have to agree on that na protocol, that if you want to ask a question, then you can raise your hand, or you can ask. So that can be a protocol, right?
सर अगर वन वे कन्वर्सेशन हो तो वो भी प्रोटोकॉल होगा.
One way से means
सर जैसे स्टूडेंट बैठे हुए हैं और लेक्चर डिलीवर हो रहा है सिर्फ.
I mean प्रोटोकॉल किसी काम के लिए होता है ना, कोई ऑब्जेक्टिव होता है. तो ओके, यू कैन डिवाइस अ प्रोटोकॉल कि इंस्ट्रक्टर कहता है कि मैं लेक्चर पढ़ाऊंगा तो आपने बोलना नहीं है किसी ने भी 3 घंटे. यू कैन थिंक लाइक दिस.
सर वो यूडीपी आई थिंक उस टाइप का प्रोटोकॉल है.
एनीवेज नहीं, प्रोटोकॉल अब टेलीविजन में जो कम्युनिकेशन हो रही है, टीवी जो है वन वे है ना. आप उधर से आ रहे हैं, आप तो वैसे तो आप स्मार्ट टीवी आना शुरू हो गए हैं, फीडबैक दे सकते हैं, लेकिन बहरहाल जो नॉर्मल टीवी है वो भी तो स्टैंडर्ड यूज कर रहा है ना कोई कम्युनिकेशन के लिए, तो वो वन वे है. ठीक है ना?
ओके सर.
Okay ji, let's move to the next slide. So let's have a look on this review question. You will have review questions to strengthen your concept. This is not a part of your exam, or no, this is not a quiz or something like that, just to strengthen your concepts. So this concludes this section. So have a look on this. Can anyone answer? We talked about end systems, right? So what is the difference between a host and end system? Can anyone tell?
सर होस्ट एंड सिस्टम एक ही चीज़ होती है.
Yes, you are right. Host and end systems are same thing. So anyone else would like to list the type of end systems? Okay, let's skip this. Okay, anyone else, please go ahead.
सर पीसीज या वर्क स्टेशन वगैरह एंड सिस्टम्स होते हैं होस्ट.
Right, bilkul. What about web server is an end system?
यस सर.
Okay, yes. So you are right. So there is no difference, and systems include these, and web server is also end system. Okay, web server is also end system. So this completes this section. Now let's move to. In fact, we have studied what is so far. We have studied what is internet, what is the protocol. Now let's move to the next topic, which is network edge. Now we'll talk about network edge. The host, access networks, and physical media. We'll do discussion related to it. Okay. So again, the same diagram which you are seeing from start of the lecture, right side diagram. So this same diagram will be used for discussion. So now let's have a closer look on internet structure. So this is network edge. Recall we said there is a network edge. So hosts, which includes clients and servers, and end system is same thing. Yeah? The systems which are located at the end of the edge of the network is known as end systems, right? So network edge. So it contains basically hosts, and host includes clients and servers. Look at these encircled devices. So they all are hosts, which includes clients and servers. Okay, ji. Now these client means the basically who's initiate request. Servers normally do not request. Servers are basically for serve. Server serves. So whenever request comes in, server responds to that request. So clients basically initiate request, and server basically they responds to those requests. And the servers are often used in data centers. Data centers, look at this. Data centers have lot of servers in it. This is network edge. Then the second category is known as access networks. Access networks and physical media. So these are access networks. So they can be wired, they can be wireless. That the network from which you access the internet, the initial network which we use to access a internet. For example, in your home, you have a wireless communication link or wired link. It depends. So you may have a group of them, both of them. For example, you are using a wireless router. Look at this. When you are using a wireless router, basically you are having a wireless communication link. If you are using a cable to get a internet access, that is wired communication link, right? Then we have network core. The third category comes about network core. So what are network core? Network core basically comprises of ISPs, and they are managed by ISPs, and it basically consists of routers. And there are routers are connected with the communi communication links, high speed links, like. But again, this is what we have, network core. So this is the network of networks. So these are the three categories of internet structure: network edge, access networks, physical media, and then we have network core. Okay, Ji? Is it okay?
Yes, sir.
Okay. Now let's proceed further. Now the question comes in, how basically to connect end system to edge router. Edge router is actually, look at this diagram, the top left. This is the first router which connects to your network core is known as edge router. Edge, the router which is located at the edge of the network, it is known as edge router. The first router which encountered by end system. Now the question is this: how to connect end systems to edge router? Now suppose if you are having a you know you are at a home, suppose, so what do you do? How you connect internet? Which service you use? जी कौन सी सर्विस यूज कर रहे हैं आप?
जैस की सर
Okay,
4G.
mobile network. So let's call it as mobile network, mobile access network. So this is an example of, one example which you can give, that how you connect the end systems to edge router using mobile access network. That is 4G or 5G. Like Jazz is a 4G, probably 5G. We don't have so far in our country 5G. So 4G probably. Then there is a Wi-Fi. Wi-Fi is also another access networks. In residential access networks, you use DSLs, digital subscriber lines, right? DSLs. So these days we use DSLs to access to edge router, the company's router organization. And then we have third category is basically institutional access networks. Like in our university, we have our local area network. In our university or company organizations, they have their own small networks, and through that network you connect to the and systems are connected to the edge router, and edge router basically connects to the rest of the internet. So these are the three ways by which one can be connected to internet through edge router. So what to look for then? Transmission rate is a very important criteria. That ideally we want to have a highest speed so that we can get connectivity in a seamless way. These days multimedia traffic is growing day by day. We want to have a look at video at a high definition videos and multimedia content. So therefore transmission rate matters. So higher the transmission rate is, better the quality of viewing is. So transmission rate of access network is an important parameter to measure the efficiency of that access network, right? And then there is another parameter, that the bandwidth which is given to which is having in that access network is dedicated or shared. Is it a dedicated bandwidth to a user, or is it shared by user? So which will be having a better quality, dedicated or shared?
Dedicated sir.
So dedicated will give you a better quality experience. But there are some networks in which this bandwidth is shared. Okay, ji, have a look on it.
सर एज राउटर वो होता है जो डायरेक्टली सर्विस प्रोवाइडर से कनेक्ट होता है
जी
एज
बिल्कुल ऐसा ही है। यस बिल्कुल ऐसा ही है।
ओके सर।
फॉर इंस्टेंस आपका जो घर के अंदर इफ यू आर यूजिंग अ डीएसएल आपका जो वो भी राउटर है बेसिकली। वो राउटर जो है आपका घर के अंदर जो डीएसएल राउटर है वो कनेक्टेड है टू योर आईएसपी, दैट इज पीटीसीएल और मे बी सम अदर आईएसपी।
ओके सर।
Okay, then there is access network. One, need to give example of shared, this thing, that cable networks, cable-based access. So this is another way of accessing a network. So this is basically a diagram. If you look at this, this is a diagram of a cable-based access network, and you see access internet. So this is what we have, that their coaxial cable is used to have a different channels. This bandwidth is divided into different channels, and some channels are used for video, television channels, and some channels are reserved for data. Look at this. For example, channel 1 to 6 are reserved for video, and then 7, 8 are data, and control channel is there. Also control is there in channel 9. So FDM is basically used. Different channels are transmitted in cable access network using FDM, frequency division multiplexing. I hope you are familiar with frequency division multiplexing, right? Then we have this CMTS. If you look at this CMTS, cable modem termination system. These days, basically what is happening here, that basically we basically you know, these cable networks, initially when it was used, it comprises mainly of coaxial cable only, but the bandwidth of a coaxial cable is not so high. Recently, what happens that your ISPs, which are providing cable-based access, they are employing hybrid kind of cable network, that from the ISP to the residential area to the, they are using optical fiber, and within the residential areas they are using coaxial cable. So for instance, so this basically methodology is known as hybrid fiber coax, HFC, that from the ISP to the near to residential area, you are using a fiber like this. This is a fiber. Look at this. And this CMTS is a cable modem termination system. So here fiber is connected to this coaxial cable, and then from here onwards, coaxial cable is used to distribute the audio, video, audio, and data, etc. So the benefit of using HFC, hybrid fiber or coax, is basically that it gives you higher speeds. It gives you higher speeds. It is asymmetric in this sense that the upload and download speeds are not same. Naturally, in case of internet, we mainly downloads. So therefore, asymmetric means that upload and download speeds are not same. So up to 40, the speeds are typical speeds for HFC is 40 Mbps to 1.2 Gbs. So down transmission rates are higher, and this is a 30 to 100 Mbps is basically upstream transmission rate. So HFC is the today's model for cable access networks. So again, as I told you earlier, that network cables, fibers attaches homes to ISP router, and this access cable access is a shared access network. Cable based access is a shared access network, means that the bandwidth is shared among users. So as the number of users grow, the bandwidth reduces. So have a look on it, and if you have any question, you are welcome.
सर इसकी बैंडविड्थ शेयर्ड होने की वजह क्या है?
वजह बेसिकली कि इसके अंदर आप एक ही सिंगल केबल होती है, और वो सिंगल केबल पूरे, ये देखिए यहाँ पे, इफ यू लुक एट दिस सिंगल केबल इज underground or maybe overhead, and this is the main reason that there is only a single cable, and that the connection is provided through the single cable to all these residents. So this is the main reason single cable is used, and the single cable basically has a certain capacity of a bandwidth, and that is basically distributed among users. If you want to have ideally, if you don't want to have a shared access, you have to give a coaxial cable from CMTS to each home, separate coaxial cable from ISP to CMTS, which is not possible, which is
ठीक हो गया
expensive. Theoretically, it's possible, but it's very expensive.
सही सही
So
सर। और ये जो
basically, जी जी,
ये जो आजकल ऑप्टिकल फाइबर डल रही है, ये भी यही चीज ही है?
नहीं मैं आप बताता हूँ आपको, नहीं ये चीज नहीं है, ये दिस इज नॉट दैट थिंग। मैं
ठीक
बताता
हो।
हूँ आपको। ओके ओके जी, so this is cable based access. Now let's move to another thing, DSLs. Now DSL has different way of doing things. Basically, first of all, DSL basically uses existing telephone lines to central office, which is known as DSLAM. Uh, Now, basically, this central office means exchange. In our common terminology, हम जो है इसको कहते हैं exchange, but in standard terminology, it is known as central office. So this is provide this DSL is provided by telephone companies, and look at this. There is a DSL modem. Is basically you can have a splitter, and basically which splits the data with voice, and then that is connected to DSLAM, digital subscriber, digital access multiplexer subscriber line access multiplexer, digital subscriber line access multiplexer. So we call it as, this is placed in in a central office or exchange, and from here the basically traffic is separated into telephone network and ISP. Now, this DSL phone line goes to internet, and then voice DSL line goes to telephone network, like here you are seeing here, right side page. Now, DSL has a unique characteristic that, first of all, this is a dedicated bandwidth. Dedicated bandwidth is provided to each user. आपने देखा कॉपर पेयर जो आपको आ रहा होता है वो सेपरेट कॉपर पेयर होता है जो आपको घर में आ रहा होता है सेपरेट. एवरी रेजिडेंस हैज अ सेपरेट कॉपर पेयर. So that's why it is a dedicated bandwidth to each user. So consequently, the data rate is comparatively higher in case of DSLs. So it can have up to 24 to 52 Mbps dedicated downstream data transmission rate, and upstream is, because it is asymmetric, ADSL. In fact, it is that asymmetric means that upload and upstream and downstream data rate is not same. This is what we call asymmetric in this nature. So this is another way of doing this thing. The third question which we have asked is optical fiber. This in DSL generally we use a copper twisted pair. Copper is used, and copper has a certain limit, uh, and you can do not go to higher speeds due to that limits, frequency, noise characteristics. So recently what happens that we are having fiber to home, FTH, fiber to home. Fiber has much higher bandwidth. So telephone companies, what they are doing is that they, instead of using a copper, now they are started using fiber directly to home, and that is also dedicated fiber to home. And recently, this service is provided in Islamabad and main cities by certain companies. So the benefit is that much higher speed in comparison to copper DSL. Okay ji, but that fiber also has a dedicated bandwidth.
सर
So this is
फाइबर
what
भी
we
तो
have.
डिवाइड की होती है स्प्लिटर्स लगा के जीपॉन्स वगैरह के नेटवर्क में, तो सर वो कैसे डेडिकेटेड हो जाएगी फिर?
बेटा आपके जो होम देखिए, अगेन आगे जाके फाइबर जो है ना, अब ये नहीं हो सकता कि आप फाइबर जब आप कहते हैं ना डेडिकेटेड मींस के एक्सचेंज से लेके सेंट्रल ऑफिस से लेके आपके यूजर तक डेडिकेटेड बैंडविड्थ है. अब डेडिकेटेड बैंडविड्थ से एक और जो आप लेते हैं, देखें आपके पास अगर लेट्स से एक फाइबर चैनल पे 1 गीगाबिट है, तो आप उसको मल्टीप्लेक्स करते हैं, उसको डिवाइड करते हैं 1 गीगाबिट्स को डिफरेंट चैनल्स में, और वो जो चैनल होता है वो आपका डेडिकेटेड होता है, राइट?
ठीक है सर.
वो चैनल डेडिकेटेड होता है. अब आपने बहुत डिटेल पूछा है तो मैं आपको बता रहा हूँ कि आपका जो चैनल होता है वो डेडिकेटेड होता है. वो चैनल जो आपको चैनल दिया जाता है वो चैनल किसी और से शेयर नहीं किया जाता.
ठीक है सर.
ओके ओके जी. So this is why what we have in home networks, we have variety of devices. We have smart devices, right? We have wired, maybe we are having a wired connection. We may be having different devices, right? So this is a example of home network. And this is going to central office. We have a cable or DSL modem. Then we have a router, DSL router. So we'll talk about this. There is a firewall built in it, and there is net. Net, we'll talk about it. This is the network address translation. So all these things are built in a single device. Then we have a wired Ethernet and Wi-Fi. So in a home, we have variety of devices. We may have a wired connection as well as wireless connection. So this is combined in a single box. आपका separate कोई नहीं होता. I hope some of you may be having a DSL connection at home. So there is a single device which is having this access point, this router, and this splitter, the modem. Okay, जी?
Yes, sir.
मॉडेम हमारा स्प्लिटर है.
उसके अंदर ये सब कुछ होता है बेटा. मॉडर्न स्प्लिटर भी उसी के अंदर होता है, सब कुछ स्प्लिटर भी होता है.
ओके सर.
राइट. उसी के अंदर राउटर होता है, उसी के अंदर एक्सेस पॉइंट होता है. ये जो चीज ये राइट लेफ्ट पे आप देख रहे हैं.
ओके सर. सर मॉडेम का क्या पर्पस होता है?
बेटा मॉडेम आपका डाटा को कन्वर्ट करता है ना, मॉड्यूलेशन करता है उसकी सिग्नल की.
ओके
ठीक
सर.
है. Okay, जी. So we'll take a small break here, and then we'll continue after break from here onwards. So let's have a कितनी मिनट की ब्रेक होनी चाहिए?
15 minutes.
Okay, let's have a 15 minutes break. Time note कर लें please.
Thank you, sir.
I assume 15 minutes are passed. आ गए हैं जी, लोग वापस आ गए हैं.
यस सर. जी सर आ गए.
Okay. Let me share the slides again. Okay, ji, just simple. And your quiz will start at 11:15, right? The quiz will start at 11:15.
Okay, sir.
Yes sir.
Thank you.
Okay, now have a look on it. The access network. Everyone is here, ji?
Yes sir. Yes sir.
Okay. Okay, ji. So this is something home network which we are talking about it. So all these devices are embedded in a single device जो आप जिसे आप DSL router भी कहते हैं into your home, and they are often combined in this single box. Now this is something. Next slide, and basically we have a wireless access network, right? And basically at your home, look at this diagram which I have shown you a little while ago also. So this is at home, you have a single device, let's call it as a router, and it has a built-in single device as router, as well as this access base station or access point, also known as access point, this thing. So I hope you have in a university, you have seen these access points at various locations. जी, कभी गौर किया ये white कलर के लगे हुए हैं जगह जगह पे.
Yes sir. Yes sir.
So these are known as access points or base stations. So, but in your home you don't see them because that is a part of a single device. But again, this access point or base station is basically responsible for wireless communication. Now, this wireless communication is a shared access network. This network is a shared access network. Let's say that you have multiple devices in your home, right? So that basically all those devices are connected to internet through this access point, and in this way they can be connected to the internet. Another way of doing the wireless activity is known as WLANs. We call them as WLANs or wireless local area networks. Now, local area network is a network within a single building, campus, or organization under one administrative control. And if that network is wireless, so we call it as wireless local area network. And we abbreviate it as WLAN. We call it as WLANs. And typically the range of it is about 100 feet within or around the building. And there are various standards for WLANs, various standards for WLANs. And for instance, these standards, let me talk about the standard organization also here. The standard organization which basically devises these standards is IEEE. So IEEE is a standard organization which basically devises standards for WLANs. And they have numbers, certain numbers. For instance, this is IEEE standard number. The old one is B, G, N. So these all are standards. The recent standard is AC, IEEE 802.11 AC. AC is a recent standard. So I hope you can see this in your mobile phones also. You need a access point to access this. And you see here in our organization also, and at your home also, you have a access point, and through that access point you get a wireless internet connectivity. There are various speeds: 11 speeds, mbps, 54 mbps, 450 mbps, and higher. So as standards are evolving, the speeds are increasing. As standards are evolving, their speeds are also increasing. And through this, basically, you get a connectivity using wireless. And let me tell you this thing also, that if you compare the speed of a wireless local area network with a wide local area network speed is much higher in comparison to wireless local area network. So that goes in gbps, gbs. Then another category of accessing internet is wide area cellular access networks. Recall that we also use our smartphones, mobile phones, to also access internet. And this wireless cellular access network is provided by mobile operator. And its range is much higher. It's up to tens of kilometers. But its speed is relatively lower than that of wireless local area network. Its speed is relatively
सर आपकी वॉइस क्लियर नहीं है. सर आपकी वॉइस लैग कर रही है.
audible to everyone, ji? Can anyone respond?
जी सर अब ठीक है.
Okay. So, as I told you earlier, that 5G is coming, and it will take at least 3 to 4 years in Pakistan. Experts say that when we will have 5G. But anyways, this is how we can have a wireless access networks through wireless LANs and through wide area cellular access networks. Have a look on it. If you have any question, you are welcome to ask. Okay, Ji, is it okay? So let's move to the next slide. Now, so far we have discussed wireless access network and also residential access by using a access network at home, right? Now we'll talk about another category of access networks, which is known as enterprise networks. We call them as enterprise networks. Enterprise networks means that companies, universities, etc., big organizations. So how they access internet? So they basically have a mix of wired and wireless technologies and switches. For example, you are seeing here, this is a sample network, and there is a separate standards for local area networks at this level. Recall that we said wireless local area network has a standard which we call it as Wi-Fi, right? Wi-Fi. And
सर आपकी वॉइस दोबारा लैग कर रही है।
AC. So these all are the names of standards for wireless access, wireless local area networks. And then you have seen wireless cellular networks, 4G. For instance, 4G is the name of standard which is used to get internet access through telephone operators, cellular operators. Now this is the third category, and the standard which is used is known as Ethernet. We call it as Ethernet. Ethernet is a standard for laying down or implementing local area network within a university or within our organization. Right, Ji? LAN is a local area network, and this is the wide LAN can be implemented with a standard which is known as Ethernet. This is also IEEE standards, and IEEE makes the standards for Ethernet, and they are known as in figures we call them 802.3 series. IEEE 802.3. Recall that wireless local area networks were having a IEEE 802 dot क्या था? किसी को याद है? जी, can anyone recall? वायरलेस लोकल एरिया नेटवर्क्स क्या थे? IEEE 80 डॉट क्या था उसके आगे?
11 सर।
जी 11 से 11 पढ़ते हैं, 11 या 11, ओके। सो 11 था, तो इन केस ऑफ वायर्ड एरिया नेटवर्क इट इज 802.3. so they have 3 series. So Ethernet is a standard, name of a standard, and it is framed by IEEE, and it is used to lay a network in an organization, universities or companies, etc. So again, you see here a switch. A single switch is here shown, but again, for instance, in our university, we have different departments, and each department through a wired network, and then we have also a mix of wireless access points also there, and these all are connected to university's router, and they can also have a switches, institutional web server, mail server, etc. And now all these are connected to each other, and then it is going to a ISP. This is how basically enterprise network is laid down. So Ethernet wide speed is much higher. Now we have even 10 Gbps. Look at the speed, maximum speed we are having. So if you compare this speed with the Wi-Fi networks, it is at the lower side. So this is something which you have to understand, that Ethernet speed is much on higher side in comparison to Wi-Fi. So look at these speeds in case of Wi-Fi, wireless access area networks, and Ethernet is having a 10 Gbps. Look at this. So this is something which you need to understand. Have a look on it, and if you have any question, you are welcome.
सर ये इंटरप्राइज लिंक को थोड़ा एक्सप्लेन कर दें, क्योंकि बीच में आपकी वॉइस चली गई थी।
इंटरप्राइज नेटवर्क से मुराद ये है कि बिग नेटवर्क, ऑर्गेनाइजेशन नेटवर्क, right? Universities network. If you compare this with a home network, home single small network hota hai na. So in an enterprise network, we have a big network, and it is owned by a single company, not many companies. Single company is having a network. For example, each university has many departments, and they are also having a network. So these networks are known as enterprise networks, organization networks, including universities, and they are owned by a single entity. For example, UT Texla network is owned by UT Texla. So UT Law has a separate network, and that is owned by their UT Law. Same is the case for organizations. Different companies can have also their, and there are hundreds or maybe thousands of clients in it. Right?
Right, sir.
Okay, Ji. Anyone want to ask any question? Welcome. Okay, Ji. If you don't have any question, let's move to this next slide. Okay, Ji. Now, again, recall that little while ago I said that chunk of data, and we call it as packets. So let's talk about it. Host basically it generates packets of data, and there is an application at each host, or we can also call it as a, packets are generated. So for example, application means a browser is an application, and when you send a request writing some page name, so basically you are going to generate a chunk of data, and that we call it as packets. So there are, a lot of data is generated by applications. So that data is basically divided into smaller chunks. That data is basically divided into smaller chunks. And these smaller chunks are known as packets. So basically you can, in another way, you can say group of bits. So thousands of bits are generated, and those bits are grouped into some number of bits, small number of bits, and that is known as packet. So this is again group of bits or group of data. So this is a packet. Packet is a standard term which is used, and it can have of L lengths. So packet size may vary, but packets can have L bits. So length is L bits. L is the general, so it can have 100, 200,000, 10,000 bits, right? So we are generically we are assigning a variable as L as its length bits. So again, application generates a data. That data is broken into smaller chunks, and we call them as packets of L bits. So in this figure, right side figure, if you look at this figure, two packets are generated, right? Two packets, L bits of each are generated by host. And then these packets are transmitted into access network. And let's say this is a net transmission link. And suppose that this is having a rate of R. We call it as transmission rate of R. So again, two packets of L bits, and they are transmitted into access network at a what rate? At a transmission rate of R, right? And this transmission rate has other names too. AKA means also known as. AKA stands for also known as. So you can also call it as
यार
link
ये
capacity.
कॉल चल सीन है वाईफाई के क्विज के दौरान
सर आपकी वॉइस नहीं आ रही।
ओके जी, आप लोगों को आवाज आ रही है मेरी?
जी सर, अब आ रही है।
जी, कैन यू हियर मी?
यस वी कैन।
जी अली?
जी सर, आ रही है आवाज।
ओके, So can you see the slides, G, also?
Yes, sir.
Okay, so we were talking about this thing. Okay, we are having a link rate also is having a link transmission rate is also having alternate names, link capacity, link bandwidth, etc. So again, what is happening here? That application is generating a message. That message is having long chunks of data, and that are divided into smaller chunks, and we call them as packets. Please do not use chunk. This is not a standard term. So this is only used for understanding purpose. So the standard term is known as packet. So you have to use a packet of length of L bits, and then there is a transmission rate R, and the packets are transmitted into the access network at a transmission rate of R. And this is a relationship. If you look at the relationship, this is a relationship. Okay, this is a relationship which we are having. Okay, Ji. So what is the mathematical relationship? So packets transmission delay. So naturally, the packet is having hundreds of bits, right? The packet is having 100 or maybe thousands of bits. So they cannot be transmitted simultaneously. They are transmitted bit by bit serially. So packets, bits are transmitted serially. So when they are transmitted serially, it will take time. It will take time to transmit the packet. So it will take some time to transmit the packet. 15 minutes तक खत्म हो जाएगी class. So it will take time to transmit the packet. Okay, ji, am I audible to everyone? Ji, Ali?
Yes, sir, you are audible.
Okay, okay. So,
Yes, sir.
so naturally, it will take time to transmit a packet. So we can consider it as a delay. So packet, there will be a delay to transmit the whole packets, right? So what is the delay? There is a relationship of mathematical relationship of it. So time needed to transmit L bit packet into a link would be L by R, where L is a size of a packet and R is a transmission rate. So this would be delay. And you know that bits and bits will be cancelled and it will be in seconds. So this is a mathematical relationship that how long it will take a packet to transmit into the link. ये link पे complete packet को link पे transmit करने के लिए कितना delay होगा? This is known as L by R. So have a look on this mathematical relationship, where L is the size of a packet, L bits, and R is a transmission rate, link transmission rate. So it is dependent on this. If you increase the number of bits, will delay increase in a packet?
Yes.
Naturally, it will increase. And if you R, what about R? If you increase R, what will happen?
Sir, delay decreases.
Delay decreases. R means कि आप transmission rate को बढ़ा रहे हैं.
Yes,
So
sir.
delay will decrease. Naturally, transmission rate बढ़ेगा तो आपका packet bits will be transmitted quickly. So in this context, delay will decrease, right? So ideally what we want, we should have a maximum R, and minimum L means that less number of bits, but again maximum R is a desired thing. The transmission rate should be maximum. So anyways, this is a relationship which you need to keep in your minds. Have a look on it. If you have any question, you are welcome.
सर ये ट्रांसमिशन रेट को किस तरह डिफाइन करेंगे, मतलब है क्या चीज ये?
जी बेटा, can you repeat?
यस सर, ये ट्रांसमिशन रेट है क्या चीज सर? कितनी टाइम में वो जा रहे हैं पैकेट्स?
जी, पैकेट नहीं, बिट्स। देखें अगेन, मैंने कहा कि चंक ऑफ बिट्स होती हैं। पैकेट में कितनी होती है? पैकेट में 1000-2000 बिट्स होती हैं। तो
सही हो।
लेट्स से वी आर हैविंग अ पैकेट ऑफ 2000 बिट्स, the time needed to transmit all those 2000 bits into the link, starting from bit 1 to 2000 bit, complete packet, right?
सही हो गया सर, वो ट्रांसमिशन रेट ठीक हो गया।
हाँ, okay ji, anyone want to ask any question? Welcome. So keep this relationship in your minds, especially what is L, what is R. Okay ji, if you don't have any question, let's move to the next slide. Now links, type of links. We have various type of links. So let's define this thing, but before we define the links types, bit is something, binary digit. I hope you are very familiar with it, and it propagates between transmitter and receiver pairs. So basically your packets, they comprises of bits. Packets comprise of number of bits, right? And what is physical link? What lies between transmitter and receiver. And physical link can be a wired or wireless. So there are two types of physical medias or links. One is known as guided media. Guided media means that signal is propagated in a solid media. It can be fiber, it can be copper, it can be coaxial. Their physical media is there. And then the other one is unguided media, that signal propagates freely in wireless radio signals. So here, in case of unguided media, signal propagates freely without any guidance. So this is what we have. The most common guided media which is used in local area networks is known as twisted pair. We call it as simply as twisted pair, but basically it is a copper twisted pair. So you will have opportunity to see it in a lab. So this is known as there are two insulated copper pairs, and there are various categories of it. So currently we have if category 5 and 6 are used. So category 5 is used for 100 Mbps, 1 Gbps internet Ethernet, and category 6 is used for 10 Gbps Ethernet. So this is what we have, twisted pair, and this is a connector, a jack, RJ, we call it as RJ45 connector, registered jack 45 connector. So this is used for guided media. Have a look on it. Is it okay, Ji? Is it okay to everyone?
Yes, sir.
Okay. Now look at coaxial cable. This is another type. So look at this. This figure is given. This is used in cable network. So we have discussed this before break. So these are two copper concentric copper conductors, and this is bidirectional, and we have a broadband, means that multiple frequency channels on a cable, and its speed is 100. Various channels are divided. It is in channel 100 Mbps per channel, around 100 Mbps per channel. This is a coaxial cable. And the third category is known as fiber optic cable. So this is a glass fiber carrying light pulses. So fiber optics, in fiber optics, transmission is done in light pulses. And if you compare the speed in between these three guided medias, fiber optic is the having highest speed. So it can have a point-to-point transmission of in hundreds of Gbps, and it has certain properties. It has low error rates. So when you have low error rates, you repeaters can be spaced far apart. Because signal attenuates, and you need repeaters to strengthen the signal. So if you have a low error rate, you can have a repeaters that take more distance in comparison to copper twisted pairs. Because it's light, so it's immune to electromagnetic noise. So this is another characteristics of fiber optic cables. So these are the three categories of physical media which are used in guided media, which is used in communication, computer communication. Have a look on it. If you have any question, welcome. Okay, Ji. If you don't have, let's move to next characteristic, wireless radio. Now, wireless means that signal is carried out in electromagnetic spectrum, and there is no physical wire, and it moves freely, right? And it can be broadcast. Broadcast means, this is a very important term which you need to understand. Broadcast is, if I give you analogy, so in a airport, there are announcements that Mr. X comes to that counter, etc. That announcement is heard by everyone. So this is broadcast. Okay, you send a data, and that is listened by everyone. That is taken by everyone. So this is known as broadcast. And I hope you are familiar with half duplex. Ji, are you familiar with half duplex?
जी sir.
So this is half duplex also. Now there are certain issues which are present inherent in wireless communication, and that is reflection of signals, abstractions by objects, and interference. So these are three main inheritance characteristics which are present in case of wireless communication. So that's why the data rate is much lower in comparison to wired networks. So these are some types. Right side of slide shows you different radio link types. For example, there can be terrestrial microwave link. It can have 45 Mbps channels, Wi-Fi up to hundreds of Mbps, cellular 10 Mbps, tens of Mbps, and satellite. So satellite has a one issue, that basically there is a round trip delay. That signal goes to the satellite and then comes back. So that's why its speed is much lower. If you compare the various speeds of radio links, so you see here that satellite is basically, or terrestrial microwave is having lower bandwidths, transmission rates. So then we have geosynchronous with versus low orbit, Earth orbit satellites. Geosynchronous means, anyone having idea? What is geosynchronous?
No, sir.
Satellites which moves with the speed of Earth. The satellite which moves with the speed of Earth. So that's why they can be have a footprint of at a constant area. For example, अगर आप पाकिस्तान के ऊपर अपने सैटेलाइट रखना है, तो आप पाकिस्तान के ऊपर सैटेलाइट ला के तो उसे कांस्टेंट स्पीड से मूव करेगा, तो हमेशा वो पाकिस्तान के ऊपर उसका फुटप्रिंट या उसकी रेंज रहेगी. So this is known as geosynchronous, that satellites which moves with the speed of Earth. But the problem is this, that there is other category, low Earth orbit satellites. Low Earth orbit satellites are near to Earth. So in comparison to geosynchronous satellites, so which will have less delay. Ji, लेस डिले किसका होगा, जियो सिंक्रोनस का या लो अर्थ ऑर्बिट का?
सर लो अर्थ ऑर्बिट का मेरे ख्याल से।
जी, लियो, we call them as LEO, low earth orbit LEO. So LEO will have less delay. So this is a good thing, right? But the problem is this, that they don't move with the speed of Earth. So you need more satellites to cover the certain area. So this is a downside of LEOs. So these are the, this completes the discussion on this slide. Have a look on it. If you have any question, welcome.
सर ये मुझे हाफ डुप्लेक्स का नहीं पता, ये बता दें।
Half duplex, that communication can be done on both sides, from sender to receiver, receiver to sender, but only in one direction at the same time, right? Half duplex means one direction at the same time. A से B और B से A दोनों तरफ communication हो सकती है, but at the same time only in one direction. This is known as half duplex.
ठीक हो गया सर,
And
सही हो गया।
full duplex means that they can communicate at the same time in both directions. This is known as full duplex.
सही है सर। ये हाफ डुप्लेक्स ये सैटेलाइट वगैरह में यूज होता है?
बेसिकली ये आपके जो वाईफाई है इसमें भी हाफ डुप्लेक्स होती है, एंटीना एक ही होता है।
सही हो गया सर, ठीक हो।
ओके जी, so this completes today's content, and we have some review questions because you have a quiz, so that's why let's finish it quickly. So let's have a look on these review questions. What is the client program? What is the server program? So I think I have briefly told you about client and server. That okay, let's have a look on it. Please read the question. I'll show you the possible answer to it. So client is a program, networking program. Normally a networking program usually has two programs, each running on a different host, communicating with each other. And a program that initiates communication is known as client. Program that initiates the communication is known as client. And typically, as I told you earlier during lecture also, client program requests and receives services from server program, right? So this is the difference between client and server. Okay, let's move to the next question. G, anyone would like to answer? HFC, hybrid fiber coaxial, is it dedicated bandwidth or shared?
Shared, sir.
So it's shared, right? Shared among users. HFC bandwidth is shared among users. So what is the transmission rate of Ethernet LAN? For a given transmission rate, can each user on LAN continuously transmit at that rate? Recall, I have shown you various speeds of Ethernet, transmission rate of Ethernet LANs. So Ethernet LAN can be of 10 Mbps, 100 Mbps, 1 Gbps, and 10 Gbps, right? And user will continuously transmit at a rate, let's say X Mbps, if user is the only person sending data. But if there are more than one active users, each user cannot continuously transmit at X Mbps. So this completes today's lecture, and by this we are conclude today's lecture. And I have already uploaded the chapter 1 on download section. मेरा हाल lecture slides नहीं है, मगर पूरा बुक का चैप्टर है, चैप्टर 1 है बुक का, राइट? तो यू कैन डाउनलोड इट, उसे डाउनलोड करें और उससे रेलेवेंट टॉपिक्स पढ़ें. So I'll advise you to study with the class, and quiz, I will inform you about quiz 1 week before quiz. जब भी क्विज होना होगा उससे एक हफ्ता पहले मैं बताऊंगा आपको, तो इसलिए साथ साथ पढ़ें ताकि आपको कोई इशू ना हो, राइट? So at the end, if anyone came late, and I can mark his or her attendance. So let me, some have given their presence through chat box. So 114 is present, 114 is absent, I assume. 142. Saad is absent. Okay. Then we have 152 is absent. Then we have 171 absent. 176. Your electronic attendance can also be there in Microsoft Teams. So just because I need to have a record of attendance, so that's why I'm calling your names. So 176 is also absent. Then 181.
Sir, 177.
181.
प्रेजेंट सर।
बेटा आप कितने लेट आई हैं क्लास में?
सर टाइम पे थी।
अच्छा, ओके ओके। 187.
Yes, sir. Present.
So
Present, sir.
क्या नाम है बेटा आपका?
मेरा नाम सर नाशिद है।
187 है रोल नंबर?
जी सर, जी सर।
Okay. Then 189 is present. 201.
यस सर।
So आप कितने लेट आए हैं? क्या नाम है आपका बेटा?
उमर फारूक।
Okay. Then we have 212. So 212 is absent. Okay, so
Excuse me, sir. Sir, 177 आपने नहीं बोला।
177 हमाद आबिद, right?
जी जी
ठीक
जी।
है, okay, present है। Okay जी, so that's all for today's lecture. Please study with the class. जी
सर काइंडली कैन यू चेक कि 72 आपने मार्क किया, क्योंकि मेरा माइक का इशू है, तो अभी भी मुझे कंफर्म नहीं कि मेरी आवाज वहां तक जा रही है या नहीं जा रही।
बेटा, I can hear you and your attendance is marked. Okay.
ओके सर, थैंक यू।
Same for me, sir. 19,64, sir.
So those देखें 114 is absent, 142 is absent, 152 is absent, 171 is absent, and 1212 is absent. 176 मैंने आपको बता दिया, 114, 142, 152, 171, 176 and 212. Rest are present as per my record. So
Okay,
I
sir.
can also, obviously you have logged into Microsoft Teams, so I can also download it from there. How long you were present, but anyways, so because I have to maintain the separate record, so that's why I noted it down. Okay, Ji. Anything else?
No, sir. Thank you.
Okay, then please take care and study with the class. Again, my advice is to study with the class if you want to get complete concepts, because once you will have many lectures, 4 or 5 lectures, so content will accumulate and it would be difficult for you to grasp all the things. And if you miss the previous concepts, it will be very difficult to catch up after 5 or 6 classes. So therefore, advice is to study with the class. So by this, we conclude today's class because of your quiz. So inshallah, next time see you next week on Wednesday. Okay, then Allah Hafiz. Take care.
Allah Hafiz, sir.